Hi everybody. Today we're going to look at how to do Lab 2. So I'm in Canvas. If you guys want to follow along, maybe you're watching this on a phone. If you want to follow along on your computer, that's fine. You can just pause the video and get caught up. So we're in Chapter 4. So Lab 2 is in Chapter 4. If you want to call it Module 4, that's fine. It's where P1 is and all the Chapter 4 stuff. And I moved the lab to the end because I changed all the due dates over the extended break. So there's an overview here that is just a Word document explaining what everything looks like. Because you're likely not printing this stuff out as you would in class, you don't really need this. You are asked to, before you do the lab, you're asked to read the Unit B Essential Synthesis. I will post a document for that. So it sort of functions the same way that our in-class Unit A Essential Synthesis worked, but it's obviously not a group work activity, but I'll post the answers just like we did before. It's just another way to study for the exam. And then here we have the little rocket ship that's an assessment, so I'm just going to go ahead and click on this. Now you're going to need to run StatKey for this. In one of my earlier videos, I showed you how to do the StatKey for this, but I'll show you some other stuff because you have to do a confidence interval as well. So let's go ahead and look at that when we get to it. So I'm just doing the quiz, so I'm logged in, quote unquote, as a student. And you can see here that the first part of it is multiple choice review. I'm not going to go over the review stuff. I'll let you guys take care of that. I'm going to go over what starts here at question 2. We have application questions. So the idea here, let me zoom in a little bit. Oh boy, that's big. Yeah, it's about as good as it's going to get. So the idea here is that 16 healthy women aged 18 to 40 were split into 2 groups. Half of the women had to drink Diet Cola, half of them had to drink water. The urine was collected for 3 hours after ingestion of the beverage, and the calcium excretion was measured. So the researchers want to know, does Diet Cola leach calcium out of the bloodstream, which would increase the amount of calcium in the urine for Diet Cola drinkers? Now it talks about an Excel file here. We don't need the Excel file because we're going to do everything in StatKey. If you really like Excel, I guess you could use it, but that's up to you. But I'm just skipping all that stuff. So you have to sort of approach this like it's a homework problem. And so it asks you for what's the parameter. So make sure you know how to find the variables, count the variables, find the parameter. That's multiple choice. Then it says here for question 3, use StatKey and the sample data provided. So this data set is built into StatKey. You're going to have to already know your null and alternative hypotheses. So I'm going to let you work on that. I'm just showing you the StatKey. All right, so let's go there now. So you have to do a hypothesis test and a confidence interval. Let's do the hypothesis test first. So it's right here, cola calcium excretion. It's in the drop-down menu. And notice it says you can edit the data. So if you want to copy this and paste it somewhere else, the data is right there. The instructions for the lab say to do at least 10,000 samples. So let's go ahead and do 10,000 samples. So based on your alternative hypothesis, you're going to click left tail, two tail, or right tail, and then you're going to Click down here at the bottom to get your p-value. And that's all it asks for. So this is how you do it. It's build in, generate a whole bunch of samples. It says at least 10,000. You'll see down here, right? The p-value for the hypothesis test, right? At least 10,000, and round to 3 decimal places. So what you have to do is you have to open a Microsoft Word document. You have this for free because it comes with Excel and PowerPoint that you guys all downloaded because you're students at LCCC. So you all downloaded that, I'm sure, so everybody has Microsoft Word. And then you're going to type the null and alternative hypothesis. So let me show you sort of how this works, okay? So you want to type something like, if you don't want to use embedded symbols, that's fine, you don't have to. So if you just want to type null, something like that, hold on, let me zoom in. So if you just want to type null and you want to say, you know, mu equals 6, obviously that's not the correct answer for this problem, but if you want to write it this way, that's fine. And for the alternative, if you want to say something like alternative, if you want to type it this way, oops, that's fine. So if you want to say mu greater than 6, you know, something like that, that's fine. I don't need any embedded symbols. I've had students spend hours and hours looking for these symbols. I don't care. I just want to know that you know what's going on. So this is not the correct answer to the problem, but this is how I want you to type it. Okay, so I'm going to show you how to cut and paste into a Word document. So I'm going to show you with a different data set. So I'm going to show you with finger taps and caffeine, because you guys already know this one. And I'm just going to do it with 1,000 samples. So for this one, this is a right tail. And then for finger taps and caffeine, actually let me do 10,000. Just to show you what it looks like. Okay, so click right tail, then change this number here to match whatever your sample statistic is. Your sample statistic is going to be in a different place for different parameters. Right, so here are the parameters, you know, mu1 and mu2. So change this to 3.5. So this is what we did earlier, right? That's the same p-value we got when we did this problem earlier. So I want you to type in the p-value rounded to 3 decimal places. So you would type this in as 0.003. Again, this is a different data set. I'm just showing you what it should more or less look like, right? So type in the sample statistic here, type in the correct tail based on your alternative hypothesis. Now, let's look at what it says here. A screenshot of the distribution. So you have to type in a null and alternative and then a screenshot. So the best way to do that is using the techniques that I pointed out earlier in class, which is use your screen grabber, your snipping tool. So I'm just going to snip this whole thing. Then I copy it, and I'm just going to paste it into this Word document. It doesn't have to be fancy. You don't have to write anything in complete sentences. Now, this is really, really giant, huge. We don't need it that big. You can shrink it down. It'll be fine, right? And then just make sure you hit enter, and it puts you down on the next line. If this is hard to read, because you might have to read this later, you can right-click on the image if you're in Microsoft Word, and then you can go down here to Format Picture. You can click on the picture icon here, Picture Corrections, and you can change the sharpness. So if you make it like 80%, it really makes it easier to read. So if you zoom back out, it looks a lot nicer, as you can see. All right, and then the last thing is the final conclusion for the hypothesis test. So you would type something like, you know, the p-value is, value is, and you would write, less than or greater than, whatever it happens to be, alpha equals 0.05. So the results are or are not statistically significant. And then you want to write another sentence about your conclusion. So if we're here, we're testing, this was finger taps versus in caffeine, this particular one that I'm doing here. Type something about the sample provides sufficient evidence, right? So statistically significant means that we have sufficient evidence. If your results are not statistically significant, then you do not have sufficient evidence to conclude the alternative hypothesis. Something like that. So that's it. And then what you do is you save this. And I had a student come up with a good idea. So I'm just going to point this out. So I'm just going to save it on my desktop, just so you don't lose it, right? So save it to your desktop. So now you'll never lose it, right? And call it something nice, make a name that I can figure out what it is. But I want you to send me a Word document, but if for some reason you can't use Microsoft Word, you can save it as a PDF document. That always works as well. All right, so that's what you have to do for question 3. So when it says that contains all this stuff, right, you gotta write your null and alternative. You don't have to use fancy symbols. Screenshot that gave me the p-value, and then a conclusion given in the context. So it's 2 sentences, right? You're going to talk about the p-value compared to alpha and whether that gives us statistical significance. Then you're going to do another sentence explaining what statistical significance means in this problem. So if the results are statistically significant, then we have sufficient evidence to conclude that the alternative hypothesis is true. And then you're going to decode the alternative hypothesis. So if we're talking about caffeine and finger tapping, in context, the sample provides evidence that caffeine increases finger taps. For something like this, we're talking about Diet Cola versus water. You'd say, we do have enough evidence that Diet Cola increases calcium excretion, or we don't, depending on if you have a statistically significant result. Then your p-value, you just type it in here. Make sure you round it. Next, you're going to use StatKey to do a confidence interval. So if you just go and look for finger taps on caffeine, will we do a bootstrap confidence interval? If you go looking for it, it's right here. So the data set that you need is built into hypothesis testing and your bootstrap confidence interval. So do a whole bunch of samples, at least 10,000. It's a confidence interval, so you click two-tail, and then write the 2 numbers down that appear at the bottom, just like you did for the homework for Chapter 3. That's basically the whole lab, guys. There's not much to it because the data set is built into StatKey. You don't have to copy and paste anything. You don't have to hide any columns or anything like that. I know you guys are excited about that. All right, and last thing, then you type in the lower and upper endpoint of your confidence intervals as separate questions. Make sure you're rounding properly or you will get it wrong. There is a tolerance, so if you're a little bit off, you'll still get credit. And then you have to interpret the confidence interval here for question 8. So, I am 95% sure that blah, blah, blah is in the confidence interval. So whatever the population parameter is. Make sure you decode the population parameter in words. Don't just say, mu or p or whatever. Make sure you say what the parameter is in words, just like we did for all of the practice problems in chapter 3. And that's it. So not a real long quiz. Sorry, lab. It says quiz because that's how we put it in Canvas. Not a real long lab. And if you guys have questions, let me know. Most students get this done in about 25 to 35 minutes. So I would recommend what it says here. Read the essential synthesis. Again, I will be posting a document for that today. And you don't have to, these instructions here are only for the online course, which does not apply to you. So, well, that's it for today, and I'll see you next video, which will be chapter 5. Thanks. Bye-bye.